All right, today we are going to crack a visual code. It's one that's hidden in some of the most common, yet, totally overlooked pieces of engineering in the world. It's like a language written in metal, and I promise, once you learn to read it, you are going to start seeing it absolutely everywhere. Okay, so take a look at these two things. At their core, they both do the same basic job, right? They control the flow of a liquid through a pipe. But just look at them. They look completely different. One is all compact and symmetrical, and the other one's kind of bulbous and honestly a little awkward looking. So the big question is, why? Well, the answer, it turns out, is written right there on their surfaces. The shape of each valve is a clue. It's a direct hint about what it's for and how it works on the inside. So let's dive in and start decoding those designs. First up, we've got the gate valve. Just notice its shape for a second. It's very linear, very symmetrical. The input and the output are directly across from each other. The whole thing just looks compact and efficient. Its shape is basically screaming that it has a very simple, very direct function.
Yeah, this valve isn't really built for subtlety. Its entire design philosophy is all or nothing. It is designed for one single decisive action.
And then we have the globe valve, which, well, it tells a totally different story. I mean, look at that bulky, round body. That's the globe part. It's not symmetrical, and its complicated shape is a huge hint that the fluid inside has to take a much more complex journey to get from one side to the other. So its design philosophy is the exact opposite of the gate valve. That complex shape isn't a mistake, it is the entire point. It's deliberately designed to interfere with the flow, all for one purpose: to achieve nuanced, precise control. So we've looked at the outside. Now, let's use those visual clues to predict what's actually happening to the fluid as it travels through each one of these. Based on what we've just seen, what do you think? You've got the straight, simple valve versus the complex, winding one. What does that suggest about the pathway inside? The shapes are telling us everything we really need to know. And yeah, you'd be totally right. The gate valve works exactly like its name suggests. There's literally a gate inside that slides up and down. When it's open, the path is completely clear. It's a straight shot with almost no resistance. And when it's closed, the path is completely blocked. Simple, effective. The globe valve, on the other hand, forces the fluid on a detour. That big, bulbous body contains an internal baffle that makes the fluid go up, through an opening, and then back down again. This S-shaped path is the entire reason for its unique shape. And that S-shaped path is what allows the valve to do something the gate valve just can't do: throttling. Throttling is the ability to precisely regulate or adjust the rate of flow, not just turn it on or off. By raising or lowering a disc into that opening, you can minutely control exactly how much gets through. It's all about that precision adjustment. All right, it's time for the big reveal. Let's connect these design clues and these internal paths directly to the specific job each valve is built for. This is where it all comes together. This table just lays it all out perfectly. The gate valve is for simple on and off jobs. Its straight path means there's very little pressure drop, which is perfect when you want maximum flow. The globe valve, though, is built for throttling. That S-shaped path gives you that fine regulation, but the trade-off is a pretty significant drop in pressure because of that obstruction. Here's the absolute simplest way to remember it. The gate valve is a light switch. It's either fully on or it's fully off. The globe valve? That's your dimmer switch. You can adjust it to any level you want in between. So now that we get the what's and the whys, let's talk about the where. Where would you actually find these two completely different design philosophies at work out there in the real world? You are going to find gate valves where all or nothing is exactly what you need. Think about the main water shutoff for your house. You either want full water pressure or you want it shut off completely in an emergency. Same deal for large-scale pipelines where you want maximum flow with minimum resistance. And globe valves? Oh, you use them every single day. The faucet on your sink that lets you adjust from just a trickle to a full blast, that's a globe valve. The knob on a radiator that controls how much hot water flows through? Yep, also a globe valve. Anywhere you need to fine-tune the flow, this is going to be your tool for the job. And just like that, you've cracked the code. You didn't need some complex engineering diagram. You just needed to look closely at the shape of an object and ask, why does it look like that? You've actually learned to read the story it's telling. So here's a final thought to leave you with. This principle, that form follows function, it is everywhere. Now that you can see the story in a simple valve, what other everyday objects are out there, just waiting for you to decode their hidden language?